For 60 years, robots have been amazing at exactly the wrong things. They can weld a car body with sub-millimeter precision and land a backflip on command. But ask one to fold a shirt in a room it has never seen. And, until very recently, it would fail in ways a toddler never would. Then, in the last 18 months, something flipped. Robots started leaving the lab, taking shifts in car factories, stacking shelves, sorting packages. And the strange part is, their bodies barely changed. What changed is what's inside. This is the story of physical AI, how artificial intelligence finally got a body, and why robots suddenly work. To see why this took so long, you need a paradox from 1988. Roboticist Hans Moravec noticed something backwards about machines. The things we find hard, calculus, chess, formal logic, are easy for computers. The things we find effortless, walking, grasping, seeing, are brutally hard. A computer beat the world chess champion back in 1997, but no machine on Earth could pick up the pieces like a 5-year-old. The reason is evolution. Reasoning is a recent invention, a few 100,000 years old, running on top of perception and movement, refined for 1 billion years. Your hands feel simple because your brain is a supercomputer devoted to them. We didn't build robots that lack our strengths. We built robots that lack our oldest, deepest skill. So for decades, engineers coped the only way they could. They scripted everything. A classic industrial robot is a puppet with a perfect memory. Move to this exact point, close the gripper, move back, repeat forever. It never learns, and it never adapts. Shift the part by 2 centimeters, and the whole dance collapses. That's why factory robots live in cages, not to protect them from us, but because they cannot see us or anything else. Scripts don't scale to the real world, because the real world refuses to hold still. Then language models rewrote the playbook for a completely different field. The lesson of the LLM era was simple. Stop programming rules and start learning from data at scale. Around 2023, roboticists asked the obvious question: what if a robot's next movement was not a line in a script, but a prediction? The result is called a vision language action model. One network takes in camera images and an instruction, like fold the shirt, and outputs the next motor command, the way a chatbot outputs the next word. Skills stopped being programmed and started being learned. And robots trained this way surprised everyone, transferring skills across objects, across tasks, and even across different robot bodies. But learning by prediction has a catch. A robot that predicts one wrong move can smash something or someone. In the last episode, we met world models, networks that learn to simulate reality and imagine futures. Physical AI is where that idea gets a job. NVIDIA's Cosmos, a world foundation model trained on 20 trillion tokens of video and robot data, exists for exactly this. Before a robot acts, it can dream the outcome, test 1,000 grips in imagination, and execute only the one that works. The mind rehearses, so the body doesn't have to guess. And rehearsal scales absurdly well, because it happens in simulation. In a physics engine, 10,000 copies of a robot can practice the same task in parallel, faster than real time. A robot can live years of experience in a single night. Randomize the simulated worlds, the friction, the lighting, the weights, and the skill becomes robust enough to survive contact with reality. Engineers call the jump sim to real. It's why a robot can be clumsy on Monday and competent on Friday, without touching a single real object in between. Nowhere is the payoff clearer than hands. For decades, robot hands were claws, 2 fingers, 1 squeeze, no feel. The newest generation is different. Figure's latest humanoid has hands with 22 degrees of freedom, dozens of tiny actuators, and fingertip sensors that detect a few grams of force. Pair hardware like that with a learned brain, and a robot can hold an egg without crushing it, thread a cable, or fold laundry. Not because someone scripted eggs, but because it has felt 1,000 things like an egg before. And in 2026, the receipts arrived. At CES, humanoids were everywhere, walking the halls, dealing cards, even boxing each other in a ring. Boston Dynamics' Electric Atlas went to work on Hyundai's factory floor in Georgia, with its entire production run already spoken for. Amazon bought a humanoid robotics startup outright, and a new business model appeared, robot as a service, at roughly $25 an hour. That number matters because it turns a robot from a science project into a line item any factory manager can approve. Analysts now expect the physical AI market to grow nearly 50% a year for the rest of the decade. Now, the honest check, because every robot demo you have ever seen was the best take. Today's humanoids still fumble, stall, and fall. Batteries last a couple of hours. A slick 2-minute clip can hide 20 failed attempts. And a factory is the easy case, structured, repeatable, forgiving. Your kitchen is a nightmare by comparison. Most experts think general-purpose home robots are still years away. But notice that the shape of the argument has changed. The question is no longer whether learned robots can work. It's how fast the reliability curve bends. And robots now improve the way software does, not the way machines do. Because here's the engine underneath it all, a data flywheel. Every robot deployed in the real world collects experience. That experience trains the next model. The next model makes robots more capable, which puts more robots in the world, collecting more experience. Language models ran this loop on text, and we know how that story went. Physical AI is starting the same loop on reality itself. The first jobs are the ones humans want least: the dull, the dirty, and the dangerous. And with aging populations and millions of unfilled factory jobs, the demand is not hypothetical. The economics, the hardware, and the intelligence have finally crossed on the same graph. So here's the idea to keep. There's a sea creature called the sea squirt. It swims until it finds a rock, attaches itself, and then digests its own brain because it will never move again. Nature's verdict is blunt. Brains exist to move bodies. For 70 years, AI was a brain in a jar, brilliant and bodiless. Now the jar is opening. The minds we trained on words are stepping into machines that share our world, our factories, and eventually our homes. Intelligence began as motion. It is returning to it. If this kind of idea interests you, subscribe. Noesis explores one idea like this at a time. Thanks for watching.